Hello, everybody. I'm going to walk you through your homework assignment. So this is ripped from today's headlines. Frito-Lay. They're quite a successful company, owned and operated by PepsiCo. Okay. I want you to read the quick facts about Frito-Lay. This is going to be what we call a real project, kind of. So here's all the questions, yada yada yada, and you're going to have to run a three-way Anova on it. But let's just take a quick look at the data. Okay, here's the data. So you got three IVs, right? They're all categorical. Bam, bam, bam. Your sales is your DV, and your district number looks just like an identifying number, so that one's not that important. But let's go ahead and cut and paste this into an SPSS. Hold on while I turn it on. Okay, we got a blank SPSS. Here's the homework. Here's a good trick. So just cut and paste just the numbers. Control C. Go up to the first square, Control V. Bam. Okay. Now let's go back in and fix these. So the first one was, I already forgot. What was the first one? First one was, here's the names of the variables. So no decimals unless you need them. And so the ID doesn't need any kind of categorize. A shelf does. Okay, so the values for the shelf. Two is middle. Three was top shelf. Okay, so those are three shelf levels, subgroups. And our store types. One was a convenience store. Two was a supermarket, like Vons or Albertsons. And three were your warehouse stores, like Costco and the other kind, warehouse stores. Okay. And our packaging, one was the individual size. Two was the family size. And three was just the bulk size, like 50 pounds for the warehouses, of course. And we need to tell them what it is. This one, it doesn't matter, just a scale. But this is an IV, it's a nominal, that's the shelf. This is the nominal store type. Last one is nominal packaging type. And our last variable is sales, so that's a regular number. Okay, so that was the hardest part, believe it or not, is putting all this stuff in here. Let's take a look, make sure we got it. It looks right in the data thing. Yeah, it does. Okay. So, first thing we're going to do is see if it's normal. Just the DV, mind you. And check for outliers. Plots, histogram, normality plots, options, don't need, click OK. Okay, so this is our normality test, right? One of the main assumptions, is the data has to be normal. So we got 21 different measurements in our group here, and there's the mean and skewed and kurtosis. Not perfect, but not that bad. Here is the Smirnoff test of normality, and it did not break the 0.05 rule. So this is bigger than 0.05, so we did not violate the assumption of normality. There's the histogram, a little bit kurtotic. Kurtotic means too many or too few measurements in the middle. And there's our normal QQ plot. Again, not perfect, but good enough to keep going. Okay, so our data is normal. Let us continue. Okay, we're going to go to Analyze, General Linear Model, Univariate, because it's only got one DV. That's going to change here pretty soon. So our DV is sales, right? It's continuous, and our IVs are all the grouping guys. Let's put you in there. Kabam. And let's see what plots we should look at. And let's kind of skip the plots this time. We will do a post hoc test on all of these guys, right? They all have a minimum of 3 groups, so that means we can do a Tukey test on all of them. And what else we got here? Options, yeah, overall options. Effect size, power, homogeneity of variance. That's another assumption that we have to check. Let's click OK, see what happens. Okay, here we go. Okay, here's everything broken down into their little subgroups. Bap, 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 bap. Here's the means of all the groups. Okay, the first thing is by shelf, right? Low, medium, and high. Second one is store type, and the third one is packaging. So it breaks it down into a bunch of different groups here with all their different means. But we need to look at the Levine's test. So it did not violate the assumption of homogeneity variance, right? Because this number is greater than 0.05, so we get to go on. So here's our main Anova table. And we're going to use this to answer practically all of the questions down below. So right off the bat, it looks like we do have a significant F. So in other words, there's an overall F. It means there's a significant difference between the groups in there somewhere. So the first IV is shelf, right? This says that there's a significant difference in the number of sales depending on which shelf you put it on. The second one is store type. And this says that there is no significant difference between the store type when it comes to the sales. And the last one is packaging. And there is a significant difference in packaging. Okay, so there's a difference in shelf and packaging, but not store type. So now let's look at the interactions. Shelf and store. Ooh, there is a serious interaction between which shelf it goes on and what store type it goes on. But that's the only interaction, right? There is no interaction between shelf and packaging and store type. Okay, so let's go ahead and look at the rest of this data real quick. Post hoc. So here's the shelf part. Oh my goodness gracious. Shelf is very, very important. You should not put it on the bottom shelf is what I'm looking at here. Right? Because there's a difference between the low and the middle. There's a difference between the low and the top, but not between the middle and the top. Okay, so the middle and the top are pretty much the same, but anything connected to that bottom shelf is not moving. So keep that in mind. Don't need subsets. And so here's the store difference. And it does look like there is a significant difference between the convenience stores and the supermarkets. But that's the only one. Okay, so there's a significant difference in the number of sales of lighties between convenience stores and supermarkets. Now let's look at the packaging differences. Yes, there's a serious difference between the packaging right off the bat. So individual and family size, yes, there's a significant difference. Individual and bulk, there's a significant difference. In fact, the only place there's not a significant difference is between the family size and the bulk. Okay. So we have what we need to answer the question. So hold on while I pull up the answer sheet. All right. Let's see. These are the answers that I got. Okay, so I totaled up their sales. It was only it was less than $500 million. Not remarkable by Frito-Lay standards, so they might not keep Lighties if it can only make a measly $0.45 billion. So the null hypotheses for all three of these are the same thing, right? There was no significant difference in sales due to shelf placement, due to store type, or due to the packaging, okay? All nulls are the same. It says that there is no significant difference anywhere, okay? So is the data suitable? We ran the Smirnoff test, yes, and it was considered normal, right? Because that number was not less than 0.05. We did the Levine's test, and again, it did not violate the assumption of homogeneity variance. Was there an omnibus F, an overall F? Yes, there was right there, 28.12. I'm going to pull up the sheet here. So that was our corrected model F, right? Bam, there's our significance. We don't write significance equals 0, 0, 0. Never, 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 never. You always write P is less than 0.001, okay? And since we're here, there's the eta squared, which is your effect size, and there's your power. So this is a very strong study, okay? So yes, there was an overall F. There's your degrees of freedom, right? 13, and your second term, degrees of freedom, is always your error term, right? 13, comma 7. Move to the next question. Was there a main effect of shelf location? Shelf location, shelf. Yes. Giant F, 116. Very small significance. So there was one for shelf. There was not a main effect for store type, right? Very small F, 1.3. Giant P. Packaging, there was a significant difference between the packaging. So there's a main effect for packaging and shelf placement, but not for store type. And there's all the F's, etc., etc. It's asking for interaction. The only interaction we found was between shelf location and store type. There's the F. There's the P value. Which simple effects would you suggest to be looked at? Well, since we have an interaction between shelf location and store type, you have like 6 different options. You could take the middle shelf only across all 3 store types, or the top shelf only against all 3 store types, etc., etc. Or you could just pick one level of the store types, like warehouse, across all 3 levels of the shelf location, right? So you would simply compare warehouses, only warehouses, with bottom, top, middle shelf locations and compare their sales. But again, there's like 6 different options here. Okay. So please list all the groups which had a significant difference. That's where your Tukey test comes in. Okay. So there was a significant difference in shelf location. The bottom and the middle, right? The bottom and the top. In fact, the bottom is not the place to go, right? There's a significant difference with the bottom and the other 2 shelves. So this tells you that the bottom shelf, people are not seeing the product or they're not buying the product. Don't know why, but the bottom is bad for your lighties. So here's your types of stores. Now remember, we did not get a main effect here, so this must be caused by the interaction. That's what's going on here. Because of the interaction, because of the shelf placement, there is a significant difference between the convenience stores and the supermarket stores in the sales. Okay, so that's what the interaction is all about. So let's go back to the packaging. There is a difference between the individual packaging and the family size and the individual and the bulk. In fact, there's a significant difference in everything except for the family size and the bulk. Okay, there is no significant difference there. All right, how many did that answer? Oh, they answered all of them. Okay, so what was the effect size? The effect size was eta squared. Let's go back to the F table. And there's your eta squared, right? And there's your power right next door. So those are those 2 questions. Those are outstanding numbers, by the way. Yes, this is a very strong and valid and reliable study because the effect size was huge and so was the power. Okay, next one. What are your chances that you made a mistake? Not you miscalculated or something. It's just that the samples were weird, or it was a payday holiday, or something strange that might have thrown off your results. You could have you have a 5% chance of making a mistake. Okay, that's when you reject the null hypothesis when you should not have, and that's what we call a type 1 error. And that's for every study, okay? And so here's the write-up. I suggest you just read it on the printout paper that I'm going to put up here. And using what we just learned here in order to increase lighties, I would suggest to the marketing department, do not put them on the bottom shelf. And you might want to think about targeting the warehouse stores because they're the ones that are moving more product than the rest of them. Okay, so that's it. I hope you liked it. MGZ out.